Graphing logarithmic functions. I'll be honest, I don't know how to graph logarithmic functions. Never bothered to learn, never will learn. But nonetheless, I can still show how to graph logarithmic functions. What you need to understand is that log base A of B equals C. This means, that is, it's the same as A to the C equals B. A to the C equals B. In other words, log base 2 of 8 is equal to 3. For one reason and one reason only. 2 cubed is equal to 8. 2 cubed is equal to 8. This is the same as 2 cubed equals 8. And since this is true, this is true. For the record, if this wasn't true, then this wouldn't be true. Now, look, log base 3 of 81 is equal to 4. Because when I multiply 3 by itself 4 times, I really do get 81. 3 to the 4th really is 81. Now, want to talk about how you might remember. Now, that sure looks like a base to me. It's the lowest thing that of A, B, and C. Now, if this meant A to the B equals C, that means that you can just ignore log. But then log has no meaning. So that's not going to be true. So the other thing is, again, assuming A is the base, if the power can't be B, then it can only be C. And that one is correct. A to the C equals B. This one makes no sense. Because it's saying that, it's saying that you can just ignore the log. If this implied A to the B equals C, well then you wouldn't need the log. Okay, let's assume that's why it doesn't work. Just for the record, there's log, but this is not A to the B. This is log base A of B. It's not log A raised to the B. But if for a second we thought that that was A to the B equals C, that is, there is no log, it's meaningless. Well, that makes no sense. So it must be, again, assuming we agree that's the base, it must be A to the C equals B. Okay. So we have that. Now, suppose that we want to graph these things. Suppose we want to graph y is equal to log base 3 of x. Well, this tells me 3 to the y equals x. 3 to the y equals x. Well, you know what? I know how to graph y equals 3 to the x, but 3 to the y equals x seems like the x and y was switched. Well, before we learned that this is y equal a to the x, where a is bigger than 1. And we learned that this is y equals a to the x, where x is between 0 and 1. Well, if I switch x and y, the graph would look like that. That is the graph x equals a to the y. Same thing over here. If I switched x and y, I would get this graph. This is our x equal a to the y. And y this time is in between 0 and 1. And here y is bigger than 1. Actually, that's not true. I apologize. A is bigger than 1. And here a is still in between 0 and 1. This should say a is in between 0 and 1. So the graph, this looks like that, which, oops, made a mistake. I apologize. Okay, let us try this one again. This is the graph y equals a to the x, where a is in between 0 and 1. This graph which I meant to draw in blue, this is the graph x equals a to the y. A is in between 0 and 1. Yeah. So these are what's in blue. Those are the two new graphs. That's when x and y are switched. So know those two graphs. So if you were literally asked to graph y equals to log base 3 of x, again, I would just say this is 3 to the y equal x. And same game as always. What makes that power 0? Y equals 0. 3 to the 0 is 1, which equals x. What makes the power 1? Y being 1. 3 to the 1 is 3. So x is 3. No difference. X is 1. Y is 0. X is 3. Y goes up 1. And now, instead of getting closer to the x-axis, we get closer to the y-axis, which means it goes like that. And we get closer to the y-axis. 2 points, nothing much different. If you were asked to graph y is equal to log base 2/3 of x, well, this tells me that 2/3 to the y is x, or x equals 2/3 to the y. X and y. This time, the power is 0 when y is 0. 2/3 to the 0 is 1. Whatever this equals, that's what x is. X equals 2/3 to the y. What makes the power 1? Y being 1. So x will be 2/3 to the 1 or 2/3. So when x is 1, I don't go up any. Now since x is going to be less than 1, let's have a bigger gap. 1/3, 2/3, 3/3, or 1. So when x is 1, y is 0. Okay, or if you prefer, when y is 0, x is 1. When x is 2/3, we go up 1, which gives me this point right here. And I have to get closer and closer to one of the axes. And unfortunately, I need to remove that. At least I need to try to remove it. Okay. This graph looks like, goes like that. Getting closer to the y-axis, and I cross my two favorite points. Now, what if we have y is equal to log base 2 of x minus 4? Well, this means 2 to the y is equal to x minus 4. Now, you can bring the 4 to the other side or not. That's up to you. But the vertex is going to be what makes that 0, which is 4, and what makes that 0, and that's y being 0. If you brought the 4 to the other side, it would have been plus 4. What makes that 0? Y being 0. What does that say? 4. That's the x value, 4. Okay. Now, let's look at this one. What makes the power 0 is y being 0. 2 to the 0 is 1, plus 4 is 5. X is 5. If the what makes this power 1? Y being 1. 2 to the 1 is 2, plus 4 more is 6. Those 2 points should be quite helpful. But we have to draw the vertex. 4, 0. That's right here. We pretend that this, for graphing purposes, that's the y-axis, and this here is the x-axis. And we have the point 5, 0, which is right there, and 6, 1, which is right here. And we have to get closer to the vertical axis. Well, there it is. That's a perfect sketch of that graph. Don't have to plot 15 different points or 4 points. 2 points, sufficient. If your teacher tells you you need to plot many points, your teacher is not correct. I'm doing it very nicely with 2 points. Suppose you want to graph this. Y equals log base 2 of x plus 1 plus 4. Now, before you can get it to be exponential, that is to get out of logs, you need to bring the 4 to the other side. Y minus 4 is log base 2 of x plus 1. Now we can say 2 to the y minus 4 is x plus 1. And the vertex is, well, what makes that 0? X being negative 1. What makes that 0? 4. Okay, so if this is the x and y axes, I go to negative 1, 4. Right here. And I'm going to pretend that my axes are right here. Okay. X and y. Well, what makes this power 0? The answer is y equaling 4. Now if you want, you can bring the 1 over. Say x is 2 to the y minus 4 minus 1. If y is 4, then the exponent will be 0. 2 to the 0 is 0, minus 1 is 0. If y is 5, the power will be 1. 5 minus 4 is 1. And 2 to the 1 is 2, minus 1 is 1. So we have 0, 4, which is that point right there. And we have 1, 5, which is this point right there. And I have to get closer to the vertical blue axes. So the graph goes like that. The graph goes like that. Now, if your teacher wants you to state that point, well, that's when y is 0. So x, just copying this, x is equal to the 0 minus 4 minus 1, which is 2 to the minus 4 minus 1, which is 1 over 2 to the 4 minus 1, and 1 over 2 to the 4 is 1 over 16, minus 1, which I'll write as 16 over 16. So again, negative 15 over 16. So that x value right there is negative 15 over 16. And we found the y-intercept. It doesn't look like it crossed at 4, but it was supposed to. And there's your perfect graph. Okay, you don't have to know how to draw log graphs. Okay, you can learn. It's not a big deal. I just prefer not to learn two graphs, or two types of graphs. Logarithmic graphs and exponential graphs. I know how to draw exponential graphs, so if you give me a log graph, I just convert it to exponential. It's not a big deal.